right, so if we look at our first problem here, we have x squared minus 81. And so first thing I would look for is there a greatest common factor? And there is not. And then we should know that our next type of factoring that we look for with a binomial is a perfect square minus a perfect square, which we call a difference of two perfect squares. And we do see that in this particular one. So we'll see that x squared is x times x, and that 81 is a negative 9 and a positive 9. If we look at number 5, we'll take and look at the binomial 18x squared minus 8, and first see if there's a greatest common factor, and there is a GCF of 2. So I have to make sure that that 2 shows up in my final answer. Now, after I factor out a greatest common factor, this very well may be my answer, but I do have to check inside these parentheses, this binomial, and see, can it factor further? Since it's a binomial, the only other factor that we would have, or factoring pattern we would have, is a perfect square minus a perfect square. And it does meet that pattern. So I'm going to drop down my 2 of the greatest common factor, and then factor the 9x squared, 3x times 3x, and then our negative 4, positive 2, and negative 2. If we look up at number 2, I'm going to take and look at my binomial for a GCF, and the GCF here is 4. So I'm going to factor out a 4 from both terms, and I'll be left with 2x squared minus 3. I then need to look to see if this factors any further. Since it's a binomial, the only other factoring pattern I have is perfect square minus perfect square. It does not fit that pattern though, so therefore this does not factor any further and is my final factored answer.